Hi everyone, my name's James Barnes with Metrology UK. Today we're taking a closer look at the Master3DGAGE from Verisurf. It is a 6-axis articulating inspection arm for general inspection, reverse engineering, in-process control and a lot more. The Master3DGAGE is made up of 6 articulating joints that go to make up the measurement volume of the device itself, allowing you maximum capability to measure any given point within the 1.2 meter capability. The system itself comes with 3 different probe types, 6mm, a 3mm and a reference probe, like so. It has a quick release mechanism which allows you to quickly release the probe and return it or change the probe to a different type very easily. And then the information regarding the probe and the calibration is kept within the chipset of the actual probe itself. As you can see, it has a hot connection right here. The system itself has counterweights that allow you to articulate without feeling any of the physical weight of the system, which is really good because if you are using it for an extended period of time, you do not want to be overexerting yourself. So it's very user-friendly, easy system to use, and you can learn how to use the physicality of the product within minutes. So we've loaded the CAD model into Verisurf. Verisurf is our software package of choice. It has a universal interface that allows interfacing to any arm, any laser, any scanner, any CMM, so that you have a single universal interface. So we've just loaded the CAD model of this part here, which is just a little demonstration piece just to give you an indication. So the number one thing, we go through a 3-step process: align, inspect, report, and to achieve that we have a very simple orientation of creating a series of targets on the actual CAD model itself that represent just target points on the component. So we will go ahead and do that, and here we go, just clicking on the surface itself, just to represent what we call 3-2-1, which is the locking mechanism for traditional alignment processes. And it's as simple as then just running them and following the sequence. After the 3rd point, you get an indication of where you are, and then we've developed a method by which we can actually after the 3rd point take the points in any given order, which is just allows additional sort of flexibility. And let's just move the orientation. So we automatically jump into what we call the build mode. So build mode allows me to touch on any part of the surface and get real-time feedback about the deviations that we actually have. Now, as you can see, we are sort of in the sort of 0.1 type mark here in this area. Now that's because the setup we have here is just for demonstration purposes, and it's purely just sort of glued back here, just rough glued with a bit of blue tack. So we're not going to get perfect indication, but this gives you an indication of the process. So we can just take simple measurements, and the arrows indicate directionality of error, magnitude of error, and we can also make alterations to these particular settings. We can also lock onto hole positions. Even though we're not directly in the hole, we can lock into the vector of a hole, which gives additional functionality. So you see here we're actually building directly into a hole position, and so it's actually giving an indication of direction of error on any given hole just by placing the probe in the hole position. which is a really useful function if you're attempting to maybe position maybe a bushing or during a digital assembly, giving you an indication of error. So what I wanted to do is just show you some additional functionality of the Master3DGAGE, just going through some of the detail of the specification. The arm itself has a 20 micron volumetric accuracy, and that can be even better when actually getting into a component itself. So it gives a really good indication of sort of the accuracy that arms have got to at this particular stage. We've sort of tested some arms and they're down to sort of 10 micron type accuracy levels and repeatability of 5 microns or so. But I just wanted to give you an indication how how we can physically visualize and articulate the arm itself within the software, and that's a really good benefit to be able to see feasibility, etc. So I'm just going to show you here. So we're just going to quickly show some of the color mapping functionality. This just allows us to take a series of singular positions on the component itself. And then when we've actually completed, we can do done, and then you see we actually get a visual color map just even from singular point positions. So that's like a really neat function. We also have continuous mode, so that allows us to go into single. Just click in here, go to continuous mode, and we will just set this. This allows us to stream data back and forth directly from the device. The sounds you hear is basically us hitting the limit, sometimes occasionally hitting the limits of the device itself, which just shows you when you get towards the periphery of the working volume, which is good to actually know. So as you can see, we get this really great indication of where the localized error is. We can illustrate that with vectors and color maps, so we can go in and we can actually directly alter how we visualize things. So we can turn off the deviations, so we can see it in those terms. We can look at the negative arrows above the job looking down, so the arrows indicate the direction of the error itself. We can obviously turn off the arrows if need be. Some people don't like to see those, so we can just look at a physical error map, which is really useful to be able to indicate where your error on your component is itself. So from once we have a particular inspection that we want to illustrate within a report structure, we can take those objects directly into our report manager, add individual screenshots showing the particular error, so we can actually take individual screenshots associated with the particular measurement that we've done, and so you can get different graphics of different, to illustrate different particular characteristics. Let's say we want to illustrate this particular region, and we can drag these into position. Everything is a drag and drop within Verisurf, which is really good for functionality, and then literally create report titles, etc, and off we go. So we just want to create a quick report. You can see we've got pass fail, and then it's just in profiles, because we set this for a plus or minus 0.12. You can see we're just failing, just obviously with the setup that we have. So obviously this is the scan data. Yeah. Okay, so that just gives you a little bit of an indication of the Master3DGAGE align, inspect and report within minutes. So I wanted to illustrate the capability of the Master3DGAGE with Verisurf for reverse engineering purposes. We were going to recreate this this complex surface using the scanning mode, and just wanted to sort of then surface through that data. So I'm going to collect data in a single point and then go to a continuous mode, and that allows me to basically take the shape of the form itself, and it allows me to scan data across the part. I don't have to take it in an organized manner, but just need to collect enough to define the physical contours. Okay, so we've taken a bit of a random sample, not too much data, but it just gives you a bit of an indicator. I'm going to now take that data set into the reverse module and go to surface patch, which is a module that allows us to create sort of lofted style surfaces from just straight point clouds. And what we can do is we can extend beyond the measurement for modeling purposes, and also offset automatically for the probe radius, because obviously this is probe center data, as you can see. Right, so I'm just going to create the surface. You can create the accuracy by increasing the UV content. This will make the surface tighter to the original data set, and as you can see, it's recreated the surface and it mimics the original surface, so that just gives you a little bit of an indicator of the accuracy of the process. What we're able to do is actually verify our reverse engineering by highlighting it, entering into the build and inspect mode, and then what we're able to do is actually physically check our reverse engineering out for accuracy levels. And as you can see, within a few microns we have replicated that surface. And where the data doesn't match, maybe you need to collect more data, but it just gives you an indication of the quality of the reverse engineering process. So that's that is basic reverse engineering with the Master3DGAGE and Verisurf. The Master3DGAGE and Verisurf is a great addition to any manufacturing company. It's a great asset to quality departments, people dealing with NPI, and just your engineering teams for exploring the initial components, in process controls, on machine verification. So it's a great addition to any company looking for such a three-dimensional digital measurement device. If you would like to know a little bit more about it, please contact us at Metrology UK, and I'd be happy to do a demonstration on your site and go through its capabilities.